Okay, we were working on the graph when that last video stopped, so let's go ahead and pick up from where we left off. So we were labeling our axes, so this is number of hours, and I see number of hours has to go from 0 to 6 1/3. So 0 is the smallest, 6 1/3 is the largest, and obviously 0 is over here. And I can make 2 boxes count as 1, 3 boxes count as 1. I see this 1/3 and I'm like, oh, I'd really like 3 boxes to count as 1. That will make it a little bit easier. So let's see if we have enough room. So 1, 2, 3. So this would be 1 hour. And see why I wanted 3. So it'd be like 1/3, 2/3, 3/3. 1 1/3, 1 2/3, 2. So that's just random why I picked 3 boxes equal 1, just because of that. So as long as you're consistent all the way across, doesn't matter how many boxes you pick. So 1, 2, 3, this would be 3. 1, 2, 3, this would be 4. 1, 2, 3, this would be 5. 1, 2, 3, this would be 6. And then that means this would be 6 1/3. And on our y-axis, the variable is h. So we label our axis h instead of y, and it's feet what? So height in feet. Does that sound right? Or height of the statue in feet? So let's write that here. Height of statue. And then we have to let the reader know what the units are, so just put feet there in parentheses. Here we told them it was hours, here we're telling them it's feet. So the height is in feet. Okay, and we're set. And you know all this stuff from the other page. I just copied it over. My X was T. This is always the X out axis, and it's hours. My Y was height, and it was in feet. Y is always the vertical axis. So I didn't make any of this up. I just got it from the front page. So now we have to decide how to label this one. We have to go from 0 to 19 here. I'm guessing we're going to have to go by ones. So 1, 2, 3, 4, 5. So every 5 I'm going to write down, just because I don't want to write 19 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 11, 12, 13, 14, 15. Ooh, we're just barely making it, huh? 16, 17, 18, 19. And you can label 22 if you want. We don't need it, but then you're consistent 5, 5, 5, 5. But I needed 19 there because I saw that on the table. So use the 4 points. Let's read up here. Make a t-table. That's done. Use the 4 points that we, from this other page, we already did that. That's done. Until the graph sculpture is melted. So you always want to know, where does this start and where does it stop? And we know those 2 points from the other page, right? And that's why we like to make you make sentences about them, so you understand. So you just don't find 19 and go, wonder what 19 is. You know now 19's how tall the statue was before it melted. And you also know from part G that it melts right here at 6 1/3 hours. So we can see where that line's going to go already. It's going to go from here to here. Label your axes with the units. We did that. Then give your graph a title. So I always tell students, do that first. Melting sculpture, or whatever you want to write, because I grade a lot of tests, and guess what? That's a common mistake by students. They forget the title. They read it and then they forget it because they get all involved in the other part. So you can say ice sculpture, whatever you want to write. Okay, so let's go ahead and graph. So 1.5 goes with 14.5. That's going to be a tricky one. I think I'm going to use my straight edge for that. So 1.5 is going to be right in the middle, right? In between 1 and 2, so it'll be right in the middle. So I'm going to use my straight edge. 14.5, this is 14, so 14.5 would be right in the middle. So we have to be in the middle. So does that look like middle? So it's 1.5, and here's 14, so it's 14.52. And then we have 4 goes with 7. So 7, I'm going to use this again. This is kind of handy. So 4 goes with 7, which would be right there. And since this is in the form y equals mx plus b, we know it's going to be a straight line. So if your points aren't lining up, do you know what I found from grading this quiz? Most of the time when students' points don't line up, it's because they didn't label their axes right. Like they went 5, 10, 15, 20. They didn't, no. Like 5 and then 6, 7, 8, 9, 10. You can't do that. You can't count one box 5 and then all of a sudden start going 6, 7, 8, 9, 10. Each box has to be the same, and you can see each box all the way up is 1, where here 3 boxes equal 1, 3 boxes equal 1, 3 equal 1. So make sure you're very careful with labeling your graphs. So every single unit has to be the same. So you can't start here with 5 and then go 6, 7, 8, because you just counted that one box as 5 and then you started counting as 1. Okay, moving on, 0 goes up to 19, and we knew that was going to be the starting spot, right? Here's the statue, and it's melting. 6 1/3, 0. We knew that was going to be a spot. That's the end spot, and you can see these are all lining up pretty nicely, aren't they? And then 2, 13, I'm going to use this again just to keep track of it. 11, 12, 13, so that'd be right there. So look at that. Bingo! Now we have to go back to what we learned last week in the packets. Every single time you draw a graph, you have to stop right now and say to yourself, I wonder if I'm going to connect the dots or if I just leave the dots. So what we learned last week in the can problem, remember going to the Grand Canyon, buying cans, and then the other one was measuring gas. You look at the x-axis and you say, do fractions make sense? Would the statue have a height at 1/3 of an hour? Yeah. 1/2 of an hour? Yeah. 0.8 hours? Yeah. 1.3 hours? Yeah. Fractions and decimals make sense when you're talking about number of hours. It's not going to jump from here to its height at 1. It's going to cover every single height as it melts. And so because fractions and decimals make sense, it's going to be a continuous graph. And that means connected. So continuous means you can draw the line and you never have to lift your pencil. And the reason it's continuous is because x values can be fractions and decimals. They don't have to be just whole numbers like how many cans of soda did you buy? 1 or 2. I can't buy 1.3. So anytime they can be fractions and decimals. Whoops. That means you connect the points. If they can't be fractions and decimals like number of soda cans, then you don't connect them. You just stop and that's your graph. So this one, it makes sense to have decimal hours, 1.3 hours, 2.9 hours, 4.1 hours. So that's why we're connecting it. So let's lay our straight edge on. And one thing you have to recognize is that this graph starts here, so don't put an arrow there. That would be getting into negative hours, and we can't do negative time. And also, it can't get lower than 0, so don't go past the x-axis, because this is when it's completely melted. So make sure your line just connects the points but doesn't go past either axis. So this is an example of a graph that would not have domain and range negative infinity to positive infinity because there's no arrows. It starts here, it stops there. This is it before it melted. This is it after it completely melted. So those are the kinds of questions you have to ask yourself as you do these. Do I connect it or don't I? Immediately go to the x-axis to decide. And ask yourself, can these x values be fractions and decimals? And look right here. That tells you that they can. Decimal, fraction. So if that's the case, then you connect the line. If you can only buy whole number of cans, you say, okay, at hour 1, I had this many cans. At hour 2, I had this many cans. And you don't connect it. And that's called discrete, remember. So this is continuous. So you have your work cut out for you. Finish your ALEKS, study your quiz, study your practice test, and that will get you ready for the test. Okay, good luck on the test. And like I said, email me if you have any questions at all. I'm happy to help. And I also gave you the link for the tutors. So use us. That's what we're here for. Bye. Good luck on your test.